Hey everyone, I picked up a triple axis magnetic sensor module, or a compass, from Amazon for about $7. It has two markings on it, HW246 and GY-271. It is an I2C interface that takes 3 or 5 volts. Turning the module over, we could see some markings that show X, Y, and Z as it correlates to this module. I gather this information would be important for mounting if you were working on a project. It came with 2 pin configurations, one to mount it in the horizontal and one vertical. I'm going to be mounting it horizontally because it's going on the dev board. The dev board is an ideal candidate for this project, and I already have my display installed on it. So I'm soldering on the headers now, working on this side of the new lab, which is not yet finished. Working with what I have. I put on a little bit too much flux that I'll have to clean up. But now I'm soldering just one pin, and I want to make sure that that is on a 90-degree angle. And once I'm sure, I solder the rest of them, and this is now done. Let's have a look at our wiring and pinout for this project. Starting with our ESP32 Do-It Dev Kit D1 that's built on top of our dev board. A 4x20 LCD module will be used to assist in development. SCL will go to pin 22. SDA will go to pin 21. Ground will go to ground. And VCC will go to VN. Bringing in our famously mislabeled 240 by 240 display module. I'll post a link to a video about this module in the top right corner. DC will go to pin 2. RES will go to pin 4. Label SDA will go to pin 23. Label SCL will go to pin 18. VCC will go to VN. And ground will go to ground. We add our compass module, the final module, into this mix. SDA to pin 21, SCL to pin 22, ground will go to ground, and VN goes to VN. Let's have a look at our resulting wiring. I've installed the compass into the breadboard of the dev board, and we can see that it is connected I2C to the ESP32. The I2C interface that this connects to is shared by multiple interfaces on the ESP32. We also have our LCD display here and our 4-row text liquid crystal display up here, also I2C interface, daisy chaining its way back. If you haven't seen the video about the creation of the dev board, I encourage you to do so. The wife and I put this together over the course of a couple of weeks, and it has some of the regularly used sensors, power management greatly simplified with this board. It was a fun and continually evolving project, so go check it out. Starting from the very beginning, I open up Visual Studio Code and I click on platformio, the bug face right there, and I'm clicking on Create New Project. And within platformio, I click on New Project in Quick Access right here. And I'm going to need to give this a project name. So I call it ESP32 Compass. And selecting a board, I know what my board is, could be the Do-It, and it comes up, so I select Do-It Dev Kit V1. It shows 3 of them. I just click one of them. Framework is Arduino. I click Finish. Now we'll wait. Everything's going to build out for this project. I'm not going to press anything until it's done. I'll speed things up here. And we're ready to go. Open to the platformio.ini file, where we're going to add an entry immediately, setting my default monitor speed for the serial output that I'll be using for debugging, 15200. Now clicking the PIO Home tab, I make my way down to the libraries on the left-hand side and click that, because we want to add some libraries now. The first of which is going to be the liquid crystal display, the 20x4 display. I hit search for PCF 8574 by Matthias Hertel. We install that now. I click Add to Project, select Project, ESP32 Compass, and click Add. I'll speed this portion up. Back to the PIO Home tab again on the top left. We're still in the Library section. I hit back. We delete our search, and now add TFT_ESPI. We'll press Search again. We see the second one on the list from Bodmer. We're going to select that one. We're going to hit Add to Project again once it loads. Select Project, ESP32 Compass, click Add, and wait for it to finish installing. We'll notice that none of the library installations had any impact on platformio INI because I had unsaved changes when I added the monitor speed. We'll see how we could fix this. Attempting to save platformio INI, it tells me that there's a newer version to compare or overwrite it. I'll choose compare, and we could see that one of them added the libraries that we installed, and the other one was me adding the monitor speed. So what I'm going to do is take the ones with the added libraries in red, lines 15 through 17 on the left, and just move it over to my copy on the right, essentially merging the two. And next time I'll remember that when I update the monitor speed to hit the save button before I install any libraries. I hit the check mark to save the changes, and we should be good. For now, we're just going to close platformio INI. We don't need it anymore. So I'm adding the includes now, TFT ESPI, and the liquid crystal display, the two libraries I just added, and we're going to try and compile it just to make sure everything's working good, not to the device, just locally. All compiling and compiling to devices will be sped up in this video. This was a success, so we're going to go back to PIO home and add the library for the compass, which I had believed to be the Adafruit library, which requires the Adafruit sensor library first, the unified sensor library. So I'm installing that now. Add to project, select project, ESP32 compass, and then add. I wait for this to finish, and then I hit the back button because now we have to install the actual library. So I erase this from the search. And I type in Adafruit HMC5883 and hit search. And we could see that unified library. I select that one. This is supposed to support this device with this chipset. So I click add to project, select project, ESP32 compass, and again I hit add and wait. Scrolling down under examples show how we might implement this for our testing purposes, what we're going to add, and how we're going to try it out. So we're going to use this information in our program. Start by adding our includes. And just a quick check to platformio INI shows because there were no unsaved changes, it added the Adafruit libraries with no problem at all. So I'll close platformio INI again, and we'll test compile once more to make sure everything works. Which it does, so we proceed. From the example, I add an instance of the sensor. Remove all this example code provided with the new program. And then I'll start copying the example from the example section. All we're really going for here is basic functionality, making sure the wiring and the hardware works. So I will test compile once more with the code now, and everything's good, so I'm going to push it right to the device. The device reboots, and I open up my serial monitor, and I see garbage coming across. Immediately, I realize that I need to set the serial to match the speed that I have in platformio.ini. Close the monitor, scroll up to serial.begin, and it's set for 9600, so we're going to have to change that to our rate of 115,200, and now I'm going to recompile it, and that should fix that problem. Compiled, I open up a terminal window again, and now we're seeing an output, and I got really excited because it looks like things are looking good until I start moving the compass around and notice that there is no change at all. So I scroll up to the top, and I scroll down to where the device connected, and I see that it did say it did connect. So I've disconnected the I2C wires to the device and restarted the app, and it still shows that it detected the device. Something's wrong with this library. After searching online, I come to find out that the Adafruit library does not work with this device, and I have to use the QMC5883L compass library. Before installing, I quickly decide to close the platformio INI tab before I continue. Now I select this library, the 5883L compass, add to project, select project, ESP32 compass, and then I click add. The library now added, I go up to platformio.ini and I remove the two Adafruit libraries from that file. Then I make my way to main, where I remove the two Adafruit includes and replace it with the include for the new library. I then delete the Adafruit device instance and replace it with an instance of the new library. I essentially delete everything else under that and replace the whole thing with the example code from the new library, which is much smaller than the one from Adafruit. This time remembering to change my baud rate to the correct value. So now we'll test it. And everything is good, so we'll push it to the device. As it starts up, looking at the terminal, immediately I could see an azimuth, and as I rotate the device or the whole dev board slowly, I could see that number changing. So we definitely have connectivity to the device now. Past 359, it rolls back to 0. We're going to move the output to the LCD display, so I add an instance of it. I know that it's on I2C interface 27. Add my basic initialization and startup code for the LCD display. It's been in several of my videos. In loop, I want to home and clear the screen each time. Add 3 more integers to be created, x, y, and z. Assign x, y, and z to 3 functions provided, getX, getY, and getZ. They're provided by the Compass library. And now we'll use simple formatting to print this out in the LCD screen, azimuth, and then on the second line, x and its value, the third line, y and its value, and the fourth line, z and its value. We'll test it, and it's good, so we'll push it. We can see the azimuth on the terminal. Let's compare it to the LCD display. The values are aligned, so it's working good. Plus we have X, Y, and Z, so we know we could trust the values in the terminal. Now at the bench, we have the compass set up with our LCD display. Things are looking good. Not ready for our screen yet, but we have it at 52, and I'm slowly going to turn it, and we can watch the X and the Y turn along with the azimuth. The Z just fluctuates a little, but it's not really moving. If I pivot in this direction, we can see the azimuth doesn't really change, but the Z moves substantially. So things are looking good here. We could see when Z hits 90 degrees, it starts going into the positive numbers in this direction. So we got our ESP32 to our 20x4. We got our compass working. We need to get this one going now. So now I'll add an instance for our TFT ESPI. Make my way to the PIO directory on the left to start our TFT config. Scroll down to libdeps, TFT ESPI. Then I'll make my way all the way down to user setup select.h. In this file, first I'm going to scroll down to line 27 and comment this one out. Then I'll scroll down to setup 24 ST7789. That's line 57 on mine. And I'm going to uncomment that one. Make my way to user setups over on the left and open that directory. Scroll down to setup 24 and open it up. I'll comment out the 3 lines for node MCU here on 30, 31, and 32. And then I'll uncomment all these lines for generic ESP32 setup 22, 23, 24, 25, 26, 27. Quickly, I review one more time the changes that I made, make sure that they're all correct, and then I make my way back to our main CPP application. There I put in the most basic initialization for a TFTP display, except I don't want the screen to be white when it starts. I want something red, because white could also be there was a problem turning on. Red will definitely show us that it's working, and that's it. So I'm going to test it, and then I'm going to push it. Let's have a look. Everything seems to be looking good. We see that our display is showing red. That's a good sign. And our compass is still working with our 20x4 display. And we could see that the compass is reacting to me turning the dev board. So we are ready for the final step in this project right here. Let me show you what my plan is for the next step. I'm by no means an artist, so my design was going to be simple. It was going to start with a circle and a dot. A triangle is a marker for the actual position, as well as the directions. Everything in the circle, including the circle, would be a sprite, and then overlaid would be a text that would have the azimuth. The azimuth value would govern the rotation of the sprite in a loop, so depending on how the compass was rotated, the sprite would rotate and match that value. This would provide for a graphical compass output. At least that was my original plan. One of the channels I'm subscribed to on YouTube is Volos Projects. It's a really great channel if you're into graphical displays for the ESP32 or the Arduino, like the LilyGo T display or other similar types of displays. Link to the channel in the description below. I highly recommend it. And you could see from these pictures here what this channel is about. And a particular project that was here about a year ago caught my attention because I think it would be a really great fit if I could get it to work for this compass project. And this is the gauge project for the LilyGo T display, and this is basically the interface as he had designed it. Let's watch some of this in action.
In this project I'm using the GY-271 display board and this rotary encoder.
This looks really cool. I'm going to check out the code in Git and see if I could implement this in the project. At the GitHub page, and I see an INO file, so this was written for Arduino IDE. I also see a font header file as part of this project. Take a quick look, and yeah, it's included fonts for this, so I'll pull that into my project too to use the fonts that came with it, sort of look the same. Back to the main file at hand. And in the file, we could expect to see a lot of extra support for motors and encoders and buttons. Here's definitions for the encoders. Right over here, we have some math for the screen that I'm going to have to look into. But right here, I see the percentages from 0 to 100. Here's our PWM for the motor. That doesn't apply to me. Duty cycle, the on-off switch. This is the interrupt for the encoder, which we won't have. So a lot of this could be removed. This is the initial setup for the TFT, actually drawing onto the screen this portion, revolutions per minute and what have you. Draw the on-off button. Here, setting up the actual sprite. I noticed the draw function was previously undeclared, but you could do that in Arduino. Here's some mathematics that supports this project right over here in the beginning. And we get into the loop section. And in the loop, we see that it's checking to see if something changed. Read the encoder, debounce logic, start filling in information that will go into the sprite image right here. There's some conditions. With all the image info updated, the sprite is pushed to the screen. Check the on-off value to change the output of the motor. In this example, a motor is used. And then we have the functions under. Here's the read encoder function that does stuff that's beyond the scope of what we're doing. And the draw on-off button also beyond the scope of what we're doing. Let's simplify and incorporate it. So I'm going to click on fonts.h on the left-hand side. In Visual Studio, I will go to my source directory where main CPP is, right-click, and click New File. And then I'll type in fonts.h. And then within this file, I will paste the contents. Errors appear in platformio in this file. They're erroneous. We see them on the bottom and the top highlighted in red, but it's absolutely fine. We click on main CPP now and continue. And now I'm going to add an include for fonts.h in quotation marks under the last include. Make some room and copy the defines right over just to ease any confusion in the programs. Don't need to rename anything. Also, all these variables that were declared, I'm going to add them right here. Some of them I've added, but most of it is the math in support of the graphics. Right here, as we see, coordinates for the screen. A couple more values. This array right here, I change it from 0 to 90 in increments of 10 to 0 to 330 in increments of 30, and also change the size, obviously, from 10 to 12, and in start from 10 to 12. Making my way to setup, I'm just going to delete all the old TFT information and replace it with the new stuff. I've modified this slightly for the new program. A lot of the functions from before are still here because they simply worked. I notice I have an error here at line 57. I'm going to have to address that it's not defined. But first I'll add the last contents of setup, and then I'll go all the way back up top and add an instance of image right here, and this should solve the problem. The errors are now cleared. We can move on. This is the math for the program to generate a lot of the coordinates. I've changed the modus from 36 to 30 on line 69, changing from 10 segments to 12 segments. I started to remove the 20x4 panel code because I'm not going to be using it anymore. I really decided to remove pretty much all the loop code because I'm going to be replacing it, except for the one serial azimuth. Renaming it value to be compatible with the new code, assigning it the value angle. Make a condition to only do changes if it's changed since the last event. Add the conversion between the angle and azimuth, as well as information about the sprite that's going to be drawn, the color, the font, the circle fill, the text color. And I'll add just one 12-step for loop for that build so far, and we'll see how we're doing with that. Give it a quick test. And now we'll push it. Quick inspection on the desk. It is working so far. It is rotating. Everything's looking good. Let's add the rest and close this project up. So I add this bottom block of code with the for loop, also including some font adjustments as well as the azimuth. And this is going to add to our graphics that will be pushed to that sprite right here. Coming up top as well, I want to add something, and this is going to be the heading. I've added a bunch of quick and dirty logic based on azimuth to determine the headings. It's nothing pretty, but this is effective. And this is not a sprite, so should the heading update, it'll write the old heading over itself in black, effectively erasing itself, and then replace itself with the new heading, and then after that, it will update the last heading as the current heading, repeating the process. One thing I realized I had to change right before I finished is line 108. I changed that from line 107. The divide by 0.360 had to be removed from this equation in order to work properly. One last check of everything, and I believe it's time to test it for the last time, so we'll hit that button now. And then we'll run it. Let's see what we got. So this was a big reveal moment on the bench. We could see as I rotate it, the azimuth corresponds to the value on the gauge. We could see the heading up top, northeast, transitions to east right over there. I'll roll it back to northeast so we could see everything that I wanted to work appears to be working properly. This was going to be the end video for the end of this project until I noticed something as I crossed 0 here. And when I crossed 0, everything fell apart because I did not account for this rollover. It wasn't in the original design. So I'm going to have to fix that right quick. Right over here at angle, I'll have to say that if angle's less than 0, add 360 to it, and that should shore it up. So we're just going to save it. We're going to try it one last time, and I think we finally got this project finished. Remembering angle's different from value, so it is possible that angle could go into the negative and break it. So this will stop it. Let's see what we got. Rotating now past the 0 to see if the bug has been addressed, and it has. Rolled right back to 359. We'll rotate the other direction back to 0, so this bug is solved. No more issues. And the delay in the loop controls the update. I find that this value is sufficient. If feature creep is your thing, this temperature, pressure, humidity sensor could easily be implemented as another sprite on the underside of this, but that's for another project. And that concludes this triple axis magnetic sensor module project connected to this LCD screen. I hope you found this video enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button for more videos like this when they come out. When the next video comes out in the series, a link will be posted in the top right corner. Code will be posted on GitHub, link provided below. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?